Okay, guys, welcome to the B section. I realized just now that some questions have the need for background knowledge before we can actually proceed with this, and it's going to take a lot of time to really get the background knowledge going. Questions like B6 and B8 of this section: write a program to merge two distinct lists into a single linked list. A linked list is quite complex for beginners, so therefore, in order not to have a clutter or a slowdown, I'm going to skip some of those type of questions. This B6 requires us to write a record, like a file, and then read from file. Now, reading from file is quite complex in a way, and I'm going to be using some binary file reading syntax in this question, and I think it needs a background about records and files themselves, so we will skip this. But I think every other thing from B5 to B12 is something that we can answer in due time, so that we can get things going, and then we can do this one later on. So I probably do a playlist where I put the hard questions or the quite complex questions in, so in case you're interested, you can jump to it. So jumping into the question of today, which is for B5, it says write a program to input a value limit. So the program is going to take a limit, right? You're going to pass it a limit, and it's going to print a table of all the odd numbers n between 3 and the limit. So if the limit is let's say 20, it's going to print out all the odd numbers between 3 and 20. So it's going to go 5, 7, 9, 11, all the way till it gets to like 19. Well, it wouldn't print that out until it checks that the value, those n's you are getting, squaring them and subtracting 1 is also divisible by 8. So you have two things here. It's supposed to print out the odd numbers that exist between 3 and your limit, but you also have to check first that squaring it and subtracting 1 is also divisible by 8. So this is the case where you bust out the modulus operator. So let's just jump into the solution and get things going. So here we have ourselves in the solution. First and foremost, we want to have a function. We're going to give it a certain name. Now, mind you, you can't put spaces between variable names. You can put underscores. You can use camel case notation, but please don't put spaces between names for your variables or your identifiers. So that's why I put everything together. Print odd divided by 8. So this is going to take something called limit. That's the number to be entered. Let's pick a random number like 50, for instance. So what do I want to do? I want to print everything that lies between 3 and 50 as far as odd numbers go. So if I was to go 3, 4, 5, 10, 11, all the way to 50, the odd numbers I want to print out between 3 and 50, that also obey the condition that that number squared minus 1 is also divisible by 8, which means whatever it is that this gives you should be a whole number. Yeah, so we want a whole number from this division. So first and foremost, we're interested in the odd numbers, and then we want to check the odd numbers using this equation, dividing them by 8 and checking if those numbers justify the conditions for this assignment to give us a whole number. So let's see the odd numbers here first that we're looking at. Say between 3 and whatever limit. So this here is our limit. Other odd numbers here will be 5, right, 7, 9, 11, 13, all the way. And then the next thing is, once we found those numbers, we also want to check this. So for 5, for instance, I'll do 5 squared minus 1 divided by 8. Does that give me a whole number? That's 25 minus 1 divided by 8, which is 24 over 8, which gives me 3. So yeah, 5 should be printed to screen. So therefore, print 5. Then check for 7. 7 squared minus 1 divided by 8. What does that give me? 49 minus 1 divided by 8. That's 48 over 8. Does 8 go there? Yeah, 6 times. So therefore, print 7. Let's check on 9. 9 squared minus 1 divided by 8. 9 squared is 81 minus 1 divided by 8, which is what? 80 over 8, which gives us 10. So therefore, print 9. So far, all these things have been answering the equation. So it seems like everything just continues to happen. But we have this set, so let's just move on to what we need to do. So the process, the steps will be to be able to count between 3 and our number, and then put if statements in place to help us check if we find any odd number. We check if it actually satisfies the second condition, and then we print it. If it's not an odd number, it skips it until it finds another odd number. This is a simple one. This is a very simple one. This explanation was just to get us in the ballpark for the solution. First and foremost, I'm going to create a function, and the function is going to return void. That's my return type. It doesn't return anything. And the name will probably be, and I'm going to give it int limit. There you have my limit, and then I'm going to create my braces. So now let's move on. Okay, so we're going to print this. We're taking a number. So first and foremost, we want to have a for loop that runs between 3 and the limit we are given. So we use a for loop for that. We can use a while loop too, but a for loop is the best because we know the number of times. You know the count we're expecting to see. For int I equals, starting from 3, I, that's your count, I less than or equal to. Now, since we are not including 50, because they're between 3 and 50, so we don't have to be less than or equal to 50. We just go I less than 50, so it goes all the way to 49. And this should be I equals 4. we are saying between 3 and 50. So it could be I less than 50 or I less than or equal to 49. So this just gives us a good range of between 4 and 49. So but we are not going to be putting the numbers here in bricked form. We are going to be putting the numbers here as the input to our function. So rather than use numbers like this, we are going to change this to be represented by this parameter that comes in. So therefore, I'm going to be choosing this less than limit, not 49's own. So I'm going to go with I less than limit, so it will be I up to 49, then I plus plus. Then I open my for loop and I start work. So first and foremost, let's take a detour on the concept modulus. Now, what is modulus? Modulus is about remainders. So if I was to divide 5 by 2, I'll get 2 remainder 1, because 2 will go in 5 2 times and I'll have a remainder of 1, right? Because normally we write 2 1 over 2. So we have a remainder of 1. If I was to do 10 divided by 4, what will I have? I'll have 2 remainder 2. Now this right here is what we get when we do a modulus operation. The values that we get when we use modulus in programming are the remainder values of our certain divisions that we engage in. So therefore, knowing this concept, we can say that if you divide an odd number by 2, you get a remainder of 1. That's a fact, right? And if you divide an even number by 2, you get a remainder of 0. So that's how you know odd numbers and even numbers. So what you do in programming to get the modulus is to use this operator, percentage operator, to represent modulus. So if I say 20 modulus 2, what this will equate to is 0. If I say 10 modulus 4, what this will equate to is 2, which is what we actually did here. So using this modulus operator, we can figure out what an odd number is or what an even number is. So therefore, let's go back to what we're doing. So here, we're trying to check. What I can do before now is to first calculate something here so that you won't get confused here. So let's do this calculation above before we put it in an if statement. So I'm going to take this whole if statement and just drag it down a bit. Before now, I'm going to declare an integer here. Let's call it int remainder. Remember to use meaningful names for your terms. So here I'm going to check remainder, and whatever the remainder is, it stores it in this variable, and then we use that variable to check in our if statement if it's an even or an odd number, and then we perform the functions this if statement grants us. So we are going to say remainder should be I modulus 2, right? That's how we check if it is an even or an odd number. Now we're looking for odd numbers, which means that the remainder should be equals to 1. We'll go here and say if remainder equals, remember this is a relational operator. This is not an assignment operator here. Don't make the mistake of putting remainder equals to. It is remainder equals, not remainder assign. If you just leave it as an equal sign, it will be remainder assign something, and that would be wrong because an if statement should take a condition. So remainder equals, if it's odd, we say 1. Right, and then we perform our next move. So here, this one will help us sort through everything that is odd or even. Only odd things we have access to this block. So next thing is to do another if statement. So let's perform another computation here. So the next computation will happen inside here, inside this block, this new block. Once we figured out all the odd numbers, we are trying to check if those numbers hold true for the expression n squared minus 1 is divisible by 8. And if it is true, then we are going to print it. So here we're going to do a final check for those numbers to see if we square that number and subtract 1 from it and we divide it by 8. We're going to get a whole number as our output, and then we're going to print out what it is that we've gotten. So normally we're supposed to write I square minus 1 and check, right? This is computation we're supposed to do. But in programming, you cannot be writing things like this. You have to break it down. And remember, precedence is given to parentheses. So to write an expression like I square minus 1, right, this is I, you're going to do it in a way where you break this down into multiplications. So you say I star I, then you want to ensure that that is the first computation that is done based on ped mass or board mass, whatever you're using. Parentheses will be executed first, followed by multiplications, then before the subtraction. So we'll do 1, then we bracket the whole thing, or you can leave it like this, but I sometimes like to keep them in brackets. So the computer starts executing from here, this inner bracket, and then once it's done with this execution, it subtracts this from it, and then you get your values. So what I need to do now is create some variables. I need to create one for the calculation that will be happening here, this calculation. So I want to have these things in some steps so that it's quite explanatory to the examiner. So I'm going to create an integer for calculations, and then I'll run that calculation here so I can get whatever value I'm supposed to get from this. So I'm going to do I star I, bracket it, and subtract 1, then bracket the whole thing. So this expression will be evaluated and then the result will be stored in this calc variable. Then I want one other variable to check if the calculated variable is divisible by 8. And so therefore, I'm trying to find things that go in whatever value we're getting here that doesn't remain anything when divided by 8. So if I have 64, for instance, and I divide it by 8, I'm supposed to get a remainder of 0. If I have 72 divided by 8, get a remainder of 0. 8 itself divided by 8, I get a remainder of 0. So I'm looking for things that this calculation variable will give me a remainder of 0.4 when divided by 8. So before I perform my if statement to check that, I want to execute that first. Just put that in another variable by itself. So I'm going to put a variable here called check div 8. So therefore, in here, I'm going to say check div 8 equals to calculation modulus 8. Whatever this expression equates to, if it's 0, it will be stored here. If it's 1, it will be stored here. And then we're going to check now. We're going to use an if statement to check if that value is 1 or 0 or whatever. So if check div 8 equals 0, which means that the number coming here is divisible by 8 completely, then I'm going to run a print statement that gives us the output. I'm going to see out I, and I'm going to put a new line. So that's basically what we need to do. One variable called remainder to help us check the remainders for the first set, because I'm trying to figure out the odd numbers between 4 and 50 of my limit. Then I'm also trying to check which number respects the n square minus 1 equation that gives a remainder of 0 when divided by 8. So I have that. This is the equation, right? This is the code for that. So let's move into program and then just code. Hope it works. So I'm bringing out my Visual Studio for this. Here we have a prep program straight up. So first and foremost, you want to declare a function outside your int main. Let it be at the top. For the exam purpose, remember to do the rituals that are necessary. Include IOStream. You don't need these other tools. Use namespace std so you don't have to put std every time you're writing. This keeps your work a little bit tidy. And then you want to declare your function. So first and foremost, we start with the function signature. You need a return type followed by a variable name, the identifier name, followed by your parameter list, then braces. So here you have it. I have void is returning nothing, right? It's just going to print out things to screen, so it doesn't have to return anything. So I'm producing the type void, and the name is print or div 8, and it's taking that number limit from wherever it's passing it in, and then it's going to execute the code in here. That will be our code. So first and foremost, I want to create those 3 variables that we talked about in our solution on our whiteboard. So I'm putting this here, one for remainders, one for the calculation of n square minus 1, and one to check if that number that the calculation yields is divisible by 8. Good. Then I need the for loop to traverse from 4 to the limit, so finding every number between 4 and the limit. So in this for loop, I'm going to have a whole lot of things going. First, I'm going to check the remainder. If it gives us a modulus of 0 or 1, and I'm going to check if the remainder is 1. If it is, I'm going to execute this. Okay, so there you have it. So I'm putting the CR statement here to help us see on screen what's going on. It's a CR statement to print I at the time it enters here. So I'll just put a statement here, say based on remainder, right? So we can see what's going on in here. Then I have another CR statement here to show us the calculations that are happening behind the scenes. So calculation. Then I have the last one. This is the official one that should be left in the code. By the time I'm done, I'll remove all of this. This is just to help us understand, to see what's going on behind the scene. So I can save this and run it. So I'm to run this. I don't think it will work yet. Yeah, it won't work because I've not called it in main. So what I have to do is call that function that I've declared. I created the function here, right? This is the function I've created. Now I need to call it. Now remember, to call a function, the actual parameter and the formal parameters must match. So therefore, what I'm going to do is simply, since it's a void function, it doesn't return anything, I don't need to create a variable that will catch what it's returning. What I need to do now is just call it. So I'll just say print, since it's asked us to input an integer, right? I'm going to give it an integer at this point. So I'm going to give it 50, like we used in the example, and I'm going to run it. So I'll save and I'll run. Yeah, so we have it here that based on the remainder, we have 5 that gets through to the if statement. Then the calculation gives us 24, which is similar to what we did on our table when we were trying to figure out what we were going to keep. 24, right, divided by 83. And so then you have for number 5, which is what is printed based on the code. We are printing out number 5. So these are the numbers that we'll have listed when we are printing out our statement. So this actually works, right? This is the code for that. But what I'll do now is just remove all these see outs, that's helping us see what's going on behind the scenes, ident it properly, and then run the code one more time. So I'll just save and then I'll run it. Here you have it, 5, 7, 9, 11, 13, 15, 17, 19, 21. So I think these are actually all the odd numbers between 3 and 50. So we didn't really need to do the first remainder part, right? But the question said between 3 and 50, that is odd, and that also satisfies the equation n squared minus 1 should be divisible by 8. So yeah, we did two-step process. It won't kill us. It's not, we won't get negative marks for that, right? But yeah, just simply writing this part of the code would have gotten us what we need. It's good to check first, get rid of all the even numbers, and then run this. So you have your code, then we call it in our main. So don't forget, after writing your functions somewhere above, call it in main. This right here is the full program you're supposed to submit. And it's simple. How many marks? That right there is, 12 marks. Juicy 12 marks, I see. So let's check the exam reports and see what they actually said. Table of integers, 3 less than n less than limit, where n squared minus 1 is divisible by 8. Program, so they're using pseudocode. Num div 8, that's what they call it. Input, output. Variables, they have limit, n, number, value, integer, blah, blah, blah. And it's a little bit crazy to understand. So all of these things are integers, right? They're all variables, but they're also integers. They're type integer. That will begin input upper limit for test. So you are told it will give you a prompt, right? So we could include a prompt in our own that will ask for an input. So okay, it will allow you to enter a value. So we can modify our code and add that. It's not a big deal. Then read limit. So it takes in that limit and then it writes n between this, does modulus of 8, the result. So for n from 3 to limit, it begins. If odd, then it will do this. So to calculate this, so it's actually checking if it's odd first, so which is why we are right. Then it will now run this and print. So do this. If then we are right, it is divisible, else right, not divisible, and then move on. So the question is, okay, only a few answers and really done well. This question requires some algorithmic development, which was beyond most candidates. I think as a little bit more expressive, it's easier that way. You don't make any mistake. You know what you're doing. You can tell that your code will run. This is quite bogus. I think it's all sorts of expressions here. That's why I really don't like pseudocode. It's based on the standards that the person who's writing it is using. So it's left for me to explain. So when they say write a program, I prefer to stick to code because then I can be sure that whatever I convey will be translated appropriately. So thank you very much for sticking around. See you in the next question, which will be B7. Yeah, bye.